It's everywhere. On your pipes, on your cars, on your weather vanes, on your trains. It's rust. You know, that orange flaky stuff that somehow forms on things you leave outside. But sometimes things aren't always what they seem. And what is often looked at as a bad situation can actually be turned into something good. It's all about how you look at things. I recently did a video project on a man who created a portrait out of dots. Each dot represented a victim of sexual abuse or rape, turning a tragic situation into a piece of art representing each victim was not alone. I had been thinking about this theme a lot, and it inspired me to approach rust, a substance that is usually seen as an annoyance and a cause of ruin, in a new way. When I started to think about it, rust actually looks pretty interesting. And I thought, what if that orange color people dread seeing on their brand new barbecues is put into the right context and controlled? Essentially, I wondered if I could paint rust onto a metal sheet to create a piece of art. So I began to look up how rust was formed, what I could do to keep rust from spreading, and what could be used to speed up the formation. I'll start by telling you what I found out about how rust forms. According to scientists at Knight Foundation Summer Institute, everything in the world is made up of chemicals, and all chemicals are made up of tiny particles called atoms. A chemical reaction occurs when atoms join together or break apart to form new and different combinations of atoms. Rust is what forms from the chemical reaction between iron and oxygen. When iron, Fe, is found in the presence of oxygen, O2, the two chemicals join together to form a new compound, iron oxide. This is shown in the formula 4Fe plus 3O2 equals 2Fe2O3. The process is called an oxidation-reduction reaction. In an oxidation-reduction reaction, electrons get transferred from one substance to another. For rust to form, iron transfers some of its electrons to oxygen. The iron atom becomes an Fe plus 3 ion because it loses the negatively charged electrons, and oxygen becomes an O negative 2 ion after it gains the electrons. When these join with a hydrogen ion, they form water. These two elements combine to form iron oxide, or rust. So how does the hydrogen ion or water help to form rust? Well, during the corrosion process, iron does not seem to react with air at all. This is because another chemical is needed to help transport the electrons for the oxidation reaction to occur. In many cases, this chemical is water. When you leave your bike outside for a long time, water droplets in the air help facilitate the transport of electrons between the iron in the bike and the oxygen in the air, causing an oxidation-reduction reaction, and ultimately causing your bike to rust. After doing a lot of research, I found out that there are everyday household solutions that can be used to oxidize iron more quickly than air and water, which is exactly what I needed since my project was due within the next couple of weeks. One of these is hydrogen peroxide. The chemical formula for hydrogen peroxide is H2O2. Peroxide is unstable, so it decomposes easily into water, H2O, and oxygen, O2. The oxygen from the chemicals combines with the iron to form iron oxide. But when I painted the hydrogen peroxide onto the metal, it didn't do anything. Just like air needs water to create rust, the hydrogen peroxide needed the help of another chemical to help in the electron transfer. So I went back to the books, or the internet, and looked for chemicals that would help the transfer of electrons or work as what scientists call a conductor. I found out that salt, or sodium chloride, works as a conductor, so I painted hydrogen peroxide onto the metal and sprinkled salt on top of it. The parts of the metal that the salt landed on immediately began to rust. The particles of salt that did not get fully dissolved into hydrogen peroxide got stuck on the surface. This created a bumpy texture. I also read that vinegar works as a conductor. Household vinegar has water and ethanoic acid in it. Because of the acidity of vinegar, not only does it facilitate the electron transport, but it also pickles, or pits the metal. This means that it breaks down the chemical bonds between the iron atoms. This destabilizes the metal and makes the corrosion by oxidation happen faster. After I learned this, I decided to mix hydrogen peroxide, salt, and vinegar together. This time I made sure the salt was completely dissolved in the liquid. I painted the solution onto the iron metal, and once again, the metal began to rust right before my eyes. I wanted to see how store-bought oxidizers compared with my homemade solutions, so I went to Michael's and bought a rust finish called Sophisticated Finish. The bottle says it is a mixture of chemicals that quickly oxidizes iron metals, and it did, but it did not rust the metal evenly. I decided to try to paint a layer of vinegar first, followed by a layer of the finish. This helped the oxidation occur evenly across the metal, but it was still not enough. So I decided to physically do what the vinegar does, and I scratched the area of iron metal that I wanted to rust with a metal file. The physical pitting of the iron metal combined with the vinegar and the sophisticated finish produced the best results for the store-bought solution. Because of this, I decided that I would start scratching all of the metal with a file before applying the solutions. This ended up helping the metal to evenly rust with all of the oxidizing agents. So my rust experimentation was going pretty well. I was finding out what I could use to speed up the oxidation of the iron, and I was producing beautiful orange and copper hues left and right. But of course, a little something went wrong, because when you're inexperienced and experimenting with chemicals, you can easily mix the wrong ones. I did more research on oxidizing agents and found out that bleach was another strong oxidizer. And because vinegar was a conductor, I decided to mix the two. What I didn't realize at the time was that vinegar combined with bleach makes chlorine, which is highly toxic. And I found this out the hard way when my mom came out to offer me some help, only to end up feeling very lightheaded, nearly fainting. She started blacking out and got very nauseous. We ended up having to call poison control. They told us that the mixture of bleach and vinegar could be fatal because it could cause a chemical burn in a person's lungs just by inhaling it. Thankfully, my mom was okay and she did not get a chemical burn in her lungs. Bleach and vinegar together did create an interesting looking rust, so even though my mom got sick, I decided to use it later when I created my final work of art. After figuring out how to make rust through a series of trial and error, with everything from air and water to toxic solutions, I set out to control my rust and make a work of controlled rust art. This part did not take much experimentation. I created stencils of the shapes I wanted to rust, laid the stencils on the metal, and then sprayed the iron metal with Rust-Oleum. The Rust-Oleum has a fish oil base, and oils help to fortify the chemical bonds between the iron atoms and provide a protective coat that keeps the metal from rusting. After spraying 3 coats of this on the areas that I didn't want to rust, I removed the stencils and began to scratch the metal, then apply the oxidizing agents to the parts I wanted to rust. The Rust-Oleum kept it from spreading, and I was able to create circles, squares, and triangles of rust. Then it was time to take it to the next level. I decided to use my oxidizing solutions to create a rust painting of something that symbolized beauty and the endless opportunity to create. For me, this was a guitar. I divided the guitar into 4 parts, each on a different sheet of iron metal. Each part was rusted using a different chemical or combination of chemicals. The first sheet was rusted with the hydrogen peroxide, vinegar, and salt combination. The second part was made using the vinegar and sophisticated finish. The third was rusted with the hydrogen peroxide and salt sprinkled on top of it. And the fourth was oxidized with the combination of the bleach and the vinegar. The color of the rust was determined by the amount of oxygen or acidity of the oxidizing agent. The sheets oxidized by the hydrogen peroxide came out very orange, whereas the acidic bleach and vinegar produced rust that was almost black. At first, the rust was a very different color on each sheet, but as time went by and the amount of oxygen they were exposed to evened out, the color also evened out. In creating a guitar painting out of rust, I turned corrosion in what is often seen as destruction into an image of an object used to write songs, soothe the mind, and bring out the beauty in the world through music. The image also symbolizes the natural ambiguity of oxidation. Oxidation may be the cause of rust, but it is also the body's first line of defense against bacteria, virus, yeast, and parasites. Even breathing oxygen is an oxidative process. Without oxidation, we would die very quickly. Not only did the image break down the boundaries between corrosion and life and destruction and creation, but it also broke down the walls between science and art, as scientific processes were used to create a symbol of musical art.